think we're ready to start. There's still one speaker supposed to join us, but we'll join as we do, I'm guessing, the introductions. So hello, everybody, and welcome to the Edge Computing and IoT Summit by Hub Security. This is actually our 7th edition of Edge and IoT, which is pretty exciting, and great to see some familiar faces, some new people joining. We have an amazing panel here, and here we start. Here we go. So thank you everyone for joining us. I'm Doron Gez, Hub Security's Chief Marketing Officer, and we're here to discuss today AI, edge computing, and cybersecurity, together with our very own Director of Solutions Engineering, Joe Thomason, alongside edge computing and IoT experts, including Sunita, Shenoy, Michael Clegg, Pieter Buteneers, Jeff Reddy, James Adenka, and Jordan Crenshaw. Thank you all for being here today. I hope I got everyone's name right. We'll start the webinar with a brief introduction by Joe on cybersecurity role in edge computing and big data, and then we'll let each one of our panelists introduce themselves briefly before we move forwards. Afterwards, we're getting a bit deeper discussion on everything related to IoT and edge computing, including challenges and solutions. As usual, we always leave time at the end for Q&A. So if you have any questions now, you can leave them on the Q&A part below the low part of your screen, and we'll get back to them later on. As I said, we have an impressive lineup of panelists today, and I'm excited to have them all introduce themselves. But first, we'll begin with a few words from Joe Thomason, Director of Hub Security's Director of Solutions Engineering, before we hand off the mic to the rest of the introductions. Joe, do you want to start?
Absolutely not, but I will anyway. Thank you, Doron.
Thank you.
So, the edge, IoT, cloud compute, all buzzwords that have different meanings depending on whom you're talking to, right? So ask somebody what the edge is and you'll get a bunch of different responses depending on who you're asking. But one thing we can all kind of agree on is no matter where we're doing our computing today, be it on the edge, be it in the data center, be it somewhere in the middle, the fog is now the new buzzword, right? Somewhere between the cloud and the data center is the fog. We all need security for these environments, and it becomes harder and harder to implement effective security when you're not in premises that you control in an environment where you have the last say as to how everything works. So how do we provide effective security for these environments, this data, in these environments that are somewhat new, somewhat nebulous to describe and define, and frankly, out of our control? So how do we do this? Doron?
Thanks, Joe, for that introduction. We'll go through the panelists now and hear briefly from each one about their role and have them introduce themselves. Sunita, would you like to start?
Sure. First of all, thank you for having me on this panel with experts here. My name is Sunita Shenoy. I'm the Director of Technology Products in the Network and Edge Business Group at Intel, with particular focus on vertical sectors such as industrial and federal solutions. Okay. I'll give a brief introduction on the edge, following what Joe just said, right? So our vision for the future is autonomous systems, whether it's in the factories or grids or healthcare. The future is where these systems are self-organizing themselves, they're self-aware of the dynamically changing environments, business needs, they're collaborating with robots and humans. And that future requires advanced technologies, and edge plays a vital role there because the workloads are becoming software defined. That means they're portable and they can reside anywhere, wherever, whether it's the cloud in the data center or whether it's the edge and on premise. Wherever there is a need for digitization, there is a need for data economy, where the value is extracted, analyzed, and actions applied real time. So for us, edge means this computing, distributed computing devices that resides across the edge, where we can manage the workloads across the edge devices.
Perfect. Thank you, Sunita, for that introduction and a few more words about the edge. We'll move over to Michael, if you can introduce yourself.
Yeah, great. Hello. So again, thank you for being here. It's exciting to be working with this team in hub security, clearly a key focus area for Edge. At Supermicro, I do business development, which is mainly for us developing partnerships. We are a hardware server manufacturer, and nothing really works without the software. So we engage with our partners to develop software. Probably most well known as a data center manufacturer, but have been building out a strong edge line, both in embedded motherboards and gateways. So we tend to focus a little more on the gateway side. And yes, security is probably the biggest consideration now. You're increasing your exposure and your attack vector significantly. You know, my personal background is I spend a lot of time selling broadband CPE, so mobile, cable, and DSL. And we went through a similar scenario then. So I do at some level, you know, they say in the industry, nothing is new. You'd be surprised how paranoid the media content people were about getting their content stolen out of a set-top box. So I think there are some lessons to be learned as to what's happened in the broadband CPE world, but definitely security is first and foremost. And so really excited to be part of this and working with this team to go forward.
Thank you, Michael. I think there's always something new, but we can discuss more of that later probably. But more to say about media and content, absolutely. Thanks for that. I actually saw that Jordan Crenshaw just joined us, and I think this would be the perfect time for you to make an introduction. Go ahead, Jordan, if you can.
Hey, thanks for having me. I'm Jordan Crenshaw, Vice President of the U.S. Chamber of Commerce's Technology Engagement Center.
Thank you. Thanks, Jordan. We'll be moving from there for a short introduction by Peter.
Yeah. Hi, guys. Thanks for having me. You can just call me Peter. That's probably easier. So I'm the Director of Engineering for Machine Learning and AI at Sage. In case you don't know Sage, you probably have received like an access code or two-factor authentication message from us, because on average, we touch every phone, I think, like 40 times per year. So we are a CPaaS company. We provide operators and large enterprises with connection over SMS, but also over voice. Uber is one of our largest clients there, but also through email. And as you know, well, we are processing lots of private data. So security is a big aspect there. We're a European company, so you know that GDPR is a very tricky thing. So we pay a lot of attention to it, but actually we are a very typical cloud company. So we have lots of people sending information to us, we process it, and then we forward it to typically operators. On top of that, we provide software for operators, but yet again, it's very centralized. So in that sense, maybe I'm a bit atypical here in the panel, since we are mainly a cloud company, but obviously we deal with a lot of edge devices in that sense, right? Thanks.
Thanks, Peter. We'll move on and for introduction by Jeff. Jeff, you have the mic.
Hi, thanks everyone for having me. My name is Jeff. I am the CEO and founder of a company called Scale Computing. Scale Computing has been doing edge for about 13 years, so long before it had a name or was cool. But we've been doing it the whole time. Our product is primarily a platform, a software platform for running applications at the edge, and I'm sure we'll talk more about the challenges that exist at the edge here. But it's effectively an operating system designed to host applications at the edge. So thanks for having me here.
Thanks, Jeff. And last in this round will be James. If you can join and give a short introduction.
Yeah, thank you. My name is James Adenka. Can you guys hear me?
Yeah, there's some noise to your mic, I think, but we get you. I think we can maybe just move it.
Yeah, I'm at the airport, so I'm
Oh.
stuck at the airport. All right. So my name is James Adenka. I'm a technical architect and a cybersecurity leader. I saw the amazing people on this call. Some of you make the products that I use. I'm one of the consumer of your product. But guess what? I benchmark the product. I'm the guy that punched the holes on that product. As much as you make it, as much as people buy it, they call me because that is my job to look for the holes and to look for how to plug it in. So you'll be hearing from me how we actually do some testing and find out some loopholes. For the guy that actually mentioned, Peter, you mentioned that you actually do a lot of private data. That is the field that I work in, the data that I don't want other people to see. So today, I think I'm part of this team. You know, I can't wait to see what amazing product is coming out. Thank you.
Thanks, James. I think this is the first time we're going live from an airport, so really appreciating that. Perfect. I think we're just about ready to start a discussion. And I would like to, I'll start with talk about a little bit about the market and technology overview about the edge. And Jeff, if you don't mind, I'd like to start with you. If I would like to ask, what is your definition for edge computing? Let's start with some basics.
Sure. As I said, we've been doing this for 13 years, so I'm well aware that edge computing is a marketing term. And for us, it's a term that means outside the data center. So much in the same way that the cloud means somebody else's data center, the edge is outside the data center. There's only two places you can run stuff, in a data center or not. And so this is the or not. Now, you know, the reality is there's a lot of different versions of that or not, right? It could be the base of a cell tower, it could be on board an oil tanker, it could be on the factory floor, it could be a remote office, right? It could be lots of these different things. You know, I think what's interesting is I've seen, you know, some analysts like Gartner cite that they expect that over the next 3 years, 75% of all data is going to be generated and processed at the edge. You know, who knows if they're correct, but I think they're directionally accurate. And the most interesting thing is that means data is going to move to or accumulate at the edge probably twice as fast as it went from the traditional data center to the cloud. So it's a fairly big shift. You know, in my mind, this is very natural. You know, we have oscillated in IT from centralized computing to distributed computing multiple times, mainframe, client server, data center, and here we are, you know, back because the bottlenecks move around, and I'm sure we'll talk about some of those bottlenecks as well. So
thanks for that. I think we'll all be reading a lot about the big shift, and we'll probably discuss this more further in this discussion. Sunita, moving to you, could you tell us a bit more about what markets have a need for edge computing, and what are some example use cases you encounter?
Yeah. So similar to what Jeff said, right? So there are multiple markets edge computing is relevant. Many vertical markets, from retail to healthcare to manufacturing to modernization of grids, are going through a digital transformation. What that means is it's AI data-driven business, improving the business outcomes using data, right? So as an example, I'll use a manufacturing or a factory, for example. Imagine a welding station in a factory where the welder is either a robotic arm or a human, right? So that data on the work output of the welding can be analyzed by a defect detection or quality improvement software that's sitting on an industrial PC or a server on the edge, right? And as you analyze the data, you can learn more about or predict how you can improve their quality to almost 99.9% accuracy, right? And in the near term, you're detecting and improving the real-time outcome. But in future, you can really improve the quality of your products by improving the AI learning protocols as well as the inference protocols on this. And that really is one of the use cases that is a driving factor for the edge computing. But along with AI comes a number of other use cases and technologies. You need to connect for example, you need to connect the devices to collect data and analyze data. Now, once you connect, cybersecurity becomes a vulnerability. So it goes on, and we can talk more about those technologies later.
Sure, I'd like to hear also a bit more about the industrial use case when we go a bit further down the road with this discussion, but very interesting. Moving to you, Jordan, if you can tell us a little bit about how AI interplays in edge computing and what the US Chamber is doing in that space.
No, I think one of the things that I think we find fascinating, one application is potential edge computing, like in the agricultural space, especially in areas where, the edge can be used for precision agriculture in areas where connectivity may not be the greatest. And I think AI has a major role to play in that space as well. I mean, for example, we know of technology where, equipment for farming can actually identify weeds and more quickly spread pesticide and cut down on costs and improve safety there. And I think AI is at the center of that. I think some of the things that we think are critically important on the AI space in order for Western countries to compete is to ensure that we have a strategy amongst allies to really advance this technology. And one of the things we've done at the U.S. Chamber of Commerce is we've actually set up a new AI commission with former Congressman John Delaney and Mike Ferguson, and we've been going around the country and in the world even doing field hearings, trying to figure out how do we regulate AI? If we're looking at issues like bias and privacy, how do we compete in an environment where countries like Russia and China are trying to win on the AI race? And from a research and development perspective. And finally, how do we get the workforce ready for artificial intelligence and what changes that may bring? So, we're doing a lot in that space and also working as Congress has introduced a new privacy bill here in the US that may actually have some problems for AI in the future. So we're tackling it from a policy perspective and an advocacy perspective. But we really do think that Edge has a lot of potential in the AI space and looking forward to see its promise.
Thanks, Jordan. Michael, moving to you, could you please tell us what role does Supermicro see for FIPS?
Yeah, so for us, just add on the comment on Edge, I think the Edge market obviously is huge. There's no real, I think, vertical that is not going to have an edge computing at some point. I do try to distinguish Edge from endpoint devices. I think those are the two clear. So when you get all the way to an endpoint device versus when you sort of at cloud edge or some kind of aggregation device or compute device at the cloud edge, that's where we play a little more. Obviously, I think for us, one of the barriers to edge, and this is raised several times, is going to be security. And before you've been doing local compute, but now you're really, again, that idea that the gateway is an aggregation point. So you're taking all this data, you're processing a huge amount of potentially privacy sensitive or information sensitive data at the edge. But generally for the edge to be useful, you also need to feed the data back into the cloud. So in how to tackle security is kind of key. I think, we moved to a model where a lot of security today is built around individual, so personal security, but we really got to move a model thinking more device security, because a lot of these devices are not going to have a human involved, right? They're going to be just aggregating machine data or aggregating intelligence data. And in that role, we definitely see FIPS. We see FIPS a little bit introduced more for sort of remote office, branch office, sort of a kind of on an extension of SASE. But I think there's a lot of scope there to complement and work with Zero Trust and really extend that down to a machine level security model as well, because that's going to be critical if we're going to have these machines aggregating and processing this data.
Thanks, Michael. I'd like to move now to Jeff and ask, what are the big growth drivers you see for edge computing?
Yeah, so I think there's really three areas that I generally see customers deploying edge in. Obviously, it's a very Michael was just saying, it's a very horizontal application. So, you know, the first is the one I think that everybody likes to talk about, which is the technical drivers for edge. So it's latency, bandwidth, connectivity, right? So this is the joke that if you're driving a Tesla in London and the data center it's talking to is in San Francisco, do you want it asking what just walked out in front of the car and do I need to stop, right? And the answer is clearly no. But there's a physics problem there, right? If you're 10,000 miles away at the speed of light, if you could go that fast, which it wouldn't, it's going to take 80 milliseconds to get an answer, and you will have already gone 14 or 15 feet in the car, right? So you need to have that decision made locally. And we see this in practice, right? You know, a customer of ours runs a global consumer brand with a bottling canning facility, fills cans move at 2,000 cans a minute down this line. They have a camera that takes a picture of the can, uses AI to determine if the can is dented or crooked or misfilled, et cetera. And about 6 feet away is this pneumatic arm that pokes out the bad cans, right? They need an answer from the application in less than 1 millisecond. Otherwise, the can is gone, right? And so you cannot do that. You can't even do that across the LAN, really. You have to make that decision local. So that's one of the reasons. The second reason, and this is one I think that often gets overlooked, but it's the practical reasons for running at the edge, right? So you know, if you're a retailer, the point of sale system, there's point of sale systems that can be cloud-based, right? There's nothing wrong with that, right? But many retailers, if you have 1,000 stores, at any time, several of those stores are probably offline, right? And you don't want to not run the point of sale system. You don't want to lose video surveillance footage, right? If the internet is down. And so they run these applications locally in the stores and in apps like that. And I mentioned at the beginning, oil tankers, right? We have a lot of maritime customers. They're offline 80% of the time, right? And they need to be able to keep running those applications. And then finally, it's been touched on, but the privacy considerations, right? And they're wide and varied, right? If I use this retail example I just gave you, you know, we've seen you know, customers using their video surveillance cameras to do things like it's kind of a cool app called Smile ML, which takes pictures of people's faces and tries to determine if they're smiling. And then you aggregate this over time in the store to see if your customers are happy. Well, you know, under most countries' interpretations of GDPR, you know, a picture of you and data about you is considered personally identifiable and can't leave the location where it was collected, right? And so you have to do that processing locally, right? In that case, in the US, this isn't the case, right? But in other countries, it certainly is the case. So, you know, those three reasons. Again, I think the one that's overlooked is this kind of, you know, just what's practical. And the reality is at the edge, you know, we see not just the modern containerized, you know, cloud native applications we were talking about before, but very often we see customers, they're going to deploy one set of infrastructure at the edge. It needs to run all the cool new stuff. It also probably is going to have a 20 or 30 or 40-year-old application that for some reason has been there the whole time, right? And you have to kind of deal with that one as well. So it's a combination of those three things.
Thanks. That was very interesting. And next time I see a Tesla, I'll be more cautious about their how fast they come towards me, depending on where the data center is. But yeah, Peter, I'd like to ask you, what are recent advantages in AI that you think will have great impact in the near future, actually?
Yeah, what you see in the domain of AI is that, well, we had a lot of change a couple of years ago around image processing, right? As Jeff mentioned before, we can recognize people, we can recognize smiling faces. That's something that we have been doing for, well, since 2015, not that long, obviously, but we have managed to achieve near human performance or even better than human performance in many image processing tasks in the last, well, 7 years. But in most recent years, like 2-3 years, we are reaching human level performance on language processing. So basically written text, interpreting what's being said, or even generating written text. So going forward, what you will see is that many systems will become significantly better at processing language, understanding what somebody's saying or what somebody's writing, and responding to that. Again, pointing back to it's been named by a couple of people, right? Around privacy. This means that lots of information that we currently spread around the world, which for now you can ignore. You can assume that most systems don't understand the written text because it's not structured, it doesn't fit in a database. That part of privacy will evade, right? Everything that you say or write that a human can understand or can interpret, it's very likely that a machine will be able to do that, and not only in the cloud, right? These things can also work on the edge. So that's something that you will see. Obviously, those are the negative consequences, but the positive thing is that you can interact more clearly with humans and provide a better service because of it, right?
Thank you. Thanks, Peter. Joe, I would like to ask you, how do edge environments differ from traditional data center and cloud service providers environments from security perspective?
It's a completely different paradigm, right? It's a different environment. So in the data center, we're used to having complete control over the servers, how they're run, how they're secured. And we give up a certain degree of that when we move data into the cloud. So when we're in the cloud, we give up a lot of that physical control of the data, and we trust that cloud security provider to provide the security for it. Cloud service provider. Security's on my mind. But we trust them to provide the security for the data. But when we go out on the edge, and let's kind of differentiate a little bit. Jeff brought up a couple of really great examples, right? The base of a cell tower is kind of like one of the things I think of. When we talk about a factory floor, that factory probably is within your four walls. And so the security paradigm has not really changed all that much. But when we talk about the base of a cell tower or in some other environment that you don't control, now you've lost most of the security aspects around there. And so there is a need to provide more physical and logical security. Those processing units, right? Those servers out there are going to be accessed probably remotely, right? They're not going to have access from a local IT staff that's going to be maintaining them. So the physical security and the logical security are both equally important and a lot different than we're used to providing on the race floor like we've done for decades.
Thanks, Joe. I think now we'll move a bit forward to deep dive into some challenges and threats and risks we see around edge. And I would actually like to start this time with James. James, can you tell us a little bit more about why data at the edge is a double-edged sword, actually?
That's a very good one. I listened to Jordan. You caught my interest. Joe and Peter, you guys caught my interest. So the reason why I mentioned all of those three people is because they actually talked about things that makes edge computing an interesting. Why is it a double-edged sword? All of you know is the edge provides speed, and it does what? It reduces the cost. Those are the good things why all of us are rushing into it. So when people talk about edge computing, we're actually talking about, can I do it as a speed faster than anybody? Processing the data faster than what will go in the cloud. That is one. I want to reduce the cost. That is number two. But guess what, guys? Even though you have all of those two things, you still have to deal with a lot of vulnerabilities. When I say vulnerabilities, we are talking about, the attack at the layer 7, which is at the application layer. Some, I think, Sunita, you said that, we are now having software defined a lot, which is true. But guess what? That comes with a lot of baggage, because now, you know, you have a very platform at the edge, which is very, very mini, is very small. You don't have a lot of resources there to mitigate threats or to mitigate an attack. So that means that, you know, a little attack, somebody know how to tweak something, it will affect you. That is number one. Number two, the network. Somebody mentioned in this panel that, that you have to remote in. I think that is coming from Joe. Yes, it is true. You have to remote in, but guess what? You remote in, that becomes a baggage for the attacker too, to get in. So looking at this, and let me say this to you, if I don't give you these, it's gonna be a little bit hard for the audience to conceptualize. Hey, we have a patient who is a multimillionaire, being taken care of at home with a lot of machine. The doctor is local. We are using edge computing so that the doctor get anything with the phone. You know, the doctor see the changes in all of the mechanics that we are taking, all of the metrics that we are taking from her, and respond. But guess what? There's a meta attack. Meta attack is a man in the middle attack, saying that your patient actually need more insulin. But guess what? The doctor doesn't know that the metrics that is responding to is not coming from the patient directly. It's coming from man in the middle attack. So the doctor keep pumping the insulin. Did you know that that is, you know, you actually killing that patient? And when that patient died, what happens? You can't blame it on hackers. People will not believe that. So this is one of the great examples for you to know that, yes, it is double-edged sword. Yes, we are protecting. At the same time, there's a much more risk at the edge. If you want to know, there's a lot of, you know, about 1.6 million attack footprint. When you have 65,000 doors that get into a system, then you should know times 3 times 5 of that is what's going to be the attack. So I'm going to stop right there, and let's see how this rolls.
Thanks, James. Sunita, going back to you, could you tell us more about some key concerns and barriers about adoption, and actually if there's any deployment challenges go with that also?
Yeah, I'll build on what James was just stating, right? So cybersecurity, everybody, it's top of mind for everyone, right? Every business owner, every solution provider, every one of us in the value chain. However, there's much to learn about this, right? So what we see, we understand the IT paradigm of cybersecurity, right? We know IT policies are about information security. So they're about scaling. How do you do software upgrades? How do you do remote management? How do you, as soon as you find a vulnerability, you'll send a patch, right? Your smartphone, you don't even know there's background updates happening on this, right? But in the world that we are in, where we're trying to digitize the operational technologies, the machines, the smart factories, the grids, which are critical infrastructures, the OT security philosophies are different, right? A few people have control over devices, the custom software, you know, and when you start to connect and you're trying to modernize, you're introducing new vulnerabilities. So these two paradigms need to come together. New security policies are coming together. New personnel and understanding of the two worlds are coming together. So there's much to learn about the two different philosophies. That is a barrier. That's also an opportunity for the ecosystem to improve our cybersecurity threats, right? The second barrier, I think Jeff alluded to this, is in the world we're in, when something's working, why fix it, right? When something's not broken, why fix it, right? So there are a lot of legacy applications in the factories that are working fine, they're making business and revenue on it. Why modernize an infrastructure when there's already something working, right? But there's technological solutions for it. We can use virtualization to bring the old and the new on the same, you know, modern hardware. You can bring AI applications, you can use legacy application using virtualization. So there is a solution, technology solution for every problem there. I think the barrier is really the people and the policies and the decision makers who make decisions to modernize these infrastructures.
Thanks, Sunita. Moving over to Michael, can you tell us a bit more about how can security be handled in IoT and edge environments?
Yeah, so I think, you know, Joe mentioned earlier on the data center, we've typically been relying on some degree of human physical security. So you've got a secure center, you've restricted access to who can get into that data center, restricted connectivity. And that clearly doesn't work at the edge, although at some level people have been relying on that today. So what we really need to do is rethink edge devices. It's also been mentioned that you can't really manage these devices locally. So it's how do you take and really what point that we've seen at Supermicro is that the amount of compute at the edge is going up dramatically. I would probably say that we've had a lot of low-end devices, Raspberry Pis, Atom class Intel devices that have been existing, and those work at an endpoint device, but at a gateway, we've really seen a lot of Xeon class devices. So really the same processes that we're running in the data center are running out at the edge. The AI component is going up significantly as well. Most of our edge devices have some sort of AI accelerator inside them as well. So these are true data center servers. They're just sort of miniaturized a little bit, but put out there at the edge. So you've got to start doing things though. You've got to remove all the management interfaces. There's no real need to manage it locally. That device itself needs to be authenticated before it can connect to the network. So you need to build in some authentication. You really want a VPN or some security between the device and the network. There's no real reason why that device should be able to run standalone. And I differentiate from what was said earlier about, when you lose your connectivity, of course, you want it to keep running. But as a device that somehow is tethered to a cloud, that way it gets its permission to operate to begin with. The other thing, Sunita made the point, a lot of operational technology, this stuff is new to them. A lot of OT protocols today are so unique to the machine that they're not really, a hacker is not going to go learn how to drive some obscure NC machine protocol. But as we move all that over to Ethernet and IP, it's exactly the same protocol that they would have in the data center. So you've got to funnel all that, traffic into the server in a controlled manner. And that's really where, we see some of the FIPS technology being ported over into this industrial OT space as creating a highly secure device environment with very restricted ports that go in and out of that device, all connected back into the cloud, has been critical in moving sort of edge security at this edge cloud going forward.
Thanks, Michael. We'll probably go deeper than that in the next part of the discussion. I would like to move to Peter and actually ask, do you think is AI biased? And if it is, how do we get rid of the bias?
Well, short answer is AI is very biased. It's extremely biased. And the reason is very simple. The data it uses is labeled by humans, and humans are biased. And the worst thing about it is that with humans, there's some nuance, right? There's like maybe a slight bias against some minority or something like that. But for these algorithms, the simplest thing it can do is learn the bias, because that's easy, right? It's very clear. Oh, you're female, or your skin is darker, or you have a strange accent, or you're Belgian like myself. You get a label, because there's like a small bias somewhere in the data set, and it looks for the most simple thing it can learn. And the bias is obviously the simplest thing it can pick up. So these algorithms are, because the human data is biased, will pick up this bias on top of it. And that forms a clear problem. I think many of you have seen this short video of a guy with a slightly darker skin trying to use a soap dispenser. And he tries and he tries, he doesn't get soap. And he put a white piece of paper on his hand, puts it under the machine, and it gets a big pile of soap, right? Because this machine was not trained with proper data. The data it was served was only white data, right? Or pale skin data, let's call it like that. So what you need to do is to make sure that you train your system with a rich set of data, and that you test and evaluate your system for possible biases. And this is very hard, right? You need to be aware, you need to basically list for yourself what are all the possible biases that can be in the data set, and then try to augment your data, saying that, for example, maybe your data has a lot, he or this guy is a smart doctor. You should turn it around. This girl or this woman is a smart doctor, right? You need to augment your data and add some examples to it. And through that process, your system does not only become more resistant to bias, but it also becomes more resistant to adversarial attacks. Since we have been talking about attacks quite a bit, this might be a good time to introduce the concept of adversarial attacks as well, which is basically an optical illusion for a machine learning or an AI algorithm. There are these experiments where you have a traffic sign, they put like a silly sticker on it. You barely see what the sticker is because it's mostly transparent. It changes the color intensity a tiny bit. But what happens is that the self-driving car that they were testing, instead of seeing a stop sign, saw a sign of, well, you can drive, I don't know, 70 miles an hour, which causes very tricky situations, right? Because if your car thinks, oh, I can just drive really fast here, I don't need to stop, well, many accidents happen, right? And these optical illusions for these AI algorithms are a clear risk. And again, what you need to do is enrich your data. Make sure that you trick your algorithms into making the mistakes that they're supposed to make against bias, against adversarial attacks, and then use those examples to retrain the algorithm and make sure that it doesn't learn those fake data or well, those bad biases and those bad situations in all.
Thanks, Peter. I would like to move and ask Jeff. Jeff, how is Edge technically different, physically and technically actually different from the data center?
Well, I think some of it's obvious, right? Depending on again where you're talking about the edge. I mean, I think Michael was talking about the fact that, you know, the edge. I mean, data centers are hot, noisy, secure places, right? You know, the edge. You can't put a server that sounds like a jet engine in the back of a coffee shop, right? That's not going to work. You can't put a server that consumes a tremendous amount of power in 10,000 locations and not notice like the drain on the power bill, right? Or the physical size matters. Like all these things make a difference in those environments. The other thing though is management at the edge is wildly different. It's actually inverted from the data center, right? So when you think about a data center, if I'm a CIO of an enterprise, I probably have 1 or 2 data centers and 1 or 2 cloud providers, right? So I'm talking about running thousands of applications on thousands of servers across 1 to 4 locations, right? The edge, you're often talking about running thousands of locations with a handful of applications at each one, right? So it's very, very different. And in the former, in the data center world, if you say, okay, we're gonna go, you're at a daily meeting, and one of the administrators gets assigned a task, and that task is going to take them 2 minutes, right? They wouldn't even write it down, right? They would just do it and not think about it twice. If I have to perform that 2-minute task 8,000 times, it's a major project, right? And so, you know, managing at sort of edge scale, right, is very different than managing at data center scale. So, you know, all these things sort of, you know, combine. And one of the things that we talk about at scale a lot is, you know, the edge is very cost sensitive. And I'm not talking about cost sensitive in the way that, okay, this server is, you know, more than that one, or I can save 20% on this software versus that one. It's because of the multiplier effect, right? This concept. I mean, I've had customers that will spec out a server that consumes 4 watts of power at idle instead of 300 watts of power at idle. Because they're going to buy 10,000 of them, right? And that electric bill's a huge difference. Like that never happens in the data center, right? I mean, we talk about, you know, green in the data center a bit, but it's not the same thing. This is hitting people's in the wallet, right? And so it makes a big difference. So, you know, but that management at the edge for us, I think, is the big thing. And you know, not just the sort of ongoing management, but what about initial deployment? Right? The concept that, okay, in the data center, I've got a new server, I'm going to deploy it. I send 2 folks down with a screwdriver and they spend 2 hours and the server's up and running. Again, what happens at the edge? Am I putting people in a truck? Do they have to do it 10,000 times? And how can you automate, you know, that? Sunita talked a lot about, you know, automation and autonomous systems out at the edge. And we think that starts from literally initial installation, right? Putting in systems that you plug in, they set themselves up, and they're off and running.
Thanks, Jeff. James, I'd like to come back to you and actually discuss a bit more. You started saying very shortly about vulnerabilities. I'd like to hear about the top vulnerabilities you see on the edge, and I'll throw another word. Not directly in comment, but I see a lot of people introduce themselves of our attendees doing a lot of work around 5G. So that's actually a general note for everyone. So we can take also address that. But in general, I'm really curious about the top of vulnerabilities for the edge. I'd like to hear some more.
Thank you so much. So guys, with what Doron just said right now, I'm going to pick, and I think that, Jordan, you mentioned about agriculture, and I'm gonna go to Michael, because you said gateway is an aggregation point. So guys, the word that I want you to walk away today with is what we call proliferation of resources. If you remember proliferation of resources, you will know exactly that that's where your vulnerability comes in. If I ask any of you today that do you actually use Alexa at home? Do you have any smart devices at home, smart TV, smartwatch, and all of those stuff? Hey, when I walk in, all of my stuff connects. My phone, everything connects. The problem that we are having today is 90% of the company that are out there, they can't even identify what is within their network or what is not. Jeff mentioned something about data center. Data center is an aggregation point. Ask anybody. You give connection to everybody. Can I get in one place and be able to infiltrate everything else? That is where your vulnerability starts. It doesn't matter if it is at application layer. It doesn't matter if it's at storage layer. It doesn't matter if it's at the network layer. It doesn't matter which one of those parts. They are all entry points to infiltrate your point. I'm going to go back to Jordan. Jordan, how will you feel if I use IoT and they all report at the edge? And guess what? In that particular farm where we have cattle and cows, I just brought one of the robot cows in just to get into the network of your IoT devices. That's all I need to do. I get in there, I'm able to access the network. Once you are able to access the network, that is it. And if I go back to Peter, I like when you said that, a lot of, that, we have bias. Guess what? For the first time in history, I am from Chicago. For the first time in history, we have what we call DDoS, the physical DDoS. I know that doesn't happen at layer one. All of you know what layer one is at the data center. Jeff, you know exactly what it is. You plug the cable in, you put it in network devices, your server, but for the first time in the store, a lot of people DDoS the store. What do I mean by that? They actually went in, all of the devices that report back, whether it is camera, it doesn't matter. Whether it's a sensor that is, reporting when somebody actually move an item so that it can call a robot to refill it back. They went into the store and they, I call it DDoS of the store. They looted the store. They damaged all of those devices. And at the end of the day, nothing was able to report back. Hey, data is the only reason why we keep the AI working. Without the data, Peter, you know that AI is useless. So data privacy is the only thing. There's a lot of things. I won't just talk about vulnerabilities. Doron, I have to talk about how we can actually make sure that it's protected. And I won't spend too much time on that. Encryption, 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 encryption. If I say anything outside that, encryption, encryption, encryption. And Michael, you said it in your statement. You said VPN. VPN is a way to encrypt the network. Guess what? The data at rest, the data at the application layer, and the data in flight. If all of those things are encrypted, guess what, guys? It will be less of a data leakage, which all of us are trying to protect anyways. So encryption, encryption, encryption. So Doron, I'm gonna hand it here with encryption. Please Please, I know it costs money to encrypt data. It doesn't matter at which layer, whether it's in flight, whether it's at rest, but please invest more in the encryption. And when you invest more, you will see that it will be so hard for those bad guys. Yes, they're out there. You don't need to be scared of them. I tell the CIO when I attend conferences, I tell the CIO, I said, hey, stop getting scared of the attackers. Why are you guys so getting scared of them? Buy the insurance. Your insurance is one of those things that I just mentioned right now. Encryption, encryption, encryption. Thank you, Doron.
Thank you, James. Before we move actually to talk a bit more about approaches and solution, I'd like to ask Peter one last question on this topic. And we talk about the challenges is, from your experience, what are the most overlooked when talking about IoT? What are the most overlooked challenges or vulnerabilities?
Well, challenges. Before I go into vulnerability, my experience with IoT is that many companies want to do IoT because it's cool. It is cool, right? We can't deny that. That's why we're all here. But lots of companies just gather data and that's it, right? They make huge piles of data and then they don't look at it. They say, yeah, but we now have all this data. We ship it off to machine learning and AI engineers like myself and say like, hey, just find something. And we can find millions of things, but it's like an unguided missile, right? We can find millions of things, but we will not create that value for you. So what's often missing is the link between, well, we have this data, but where is the value, right? What can we get from that? And that's the part that's missing. What I want to add, because James was so heavy on encryption, I want to add a small bit on encryption is actually you can use AI to encrypt, which is, well, it's not the best encryption. It's probably pretty easy to crack, but you remove a lot of information from the data. You can use AI on the edge to extract information from the data, only the information that's relevant for the models, and then ship it off to the cloud and process it there. An example that we use, even though we're a cloud company, we do it in our data centers, but we do it because we need to process millions of messages per second. So we take a fingerprint of a message, and that fingerprint is just like a hash. But with the difference is that if you make a small difference to the message, that the hash stays the same, opposed to a typical hash, which if you change a small bit, that it becomes something completely different. And this fingerprint, this hash, we use to compare it to known, in our case, it's mainly fraud, to known fraudulent messages and see, oh, this is a phishing URL that we have seen before, so we can intercept it. And the nice thing about this hash is that you cannot reduce these 64 bits that you have, or 228 bits, into something that resembles the original message, because you have many things that can result in the same hash. So again, you encrypt things, but at the same time, you use this encryption to your benefit. You extract the necessary information from it, then you process the message, or you ship it off to the cloud without, well, bad players being able to extract other information from it than whatever you are extracting at the moment, right? And yes, it's not fully encrypted, but it does help.
Thanks, Peter. I think now after that we talked quite a lot and about the challenges and the risks and threats actually James started a bit, but let's talk a bit about solutions and what can be done. So I would like again to go back to Sunita and ask, what about connectivity? How do you see it? Is wireless the future?
Good question. I was just thinking that we talked about AI, we talked about cybersecurity, but the underpinning technology that brings all of these together is connectivity, right? And connectivity, the old way of doing things, particularly in this operational technologies, is proprietary, right? It was proprietary protocols, field bus protocols, and so on. We're now connecting it to standard Ethernet, right? And there are new standards that we're focusing on, like time-sensitive networking. So when we talk about edge, we're talking about, like I said, extracting, analyzing, and applying actions real time. And when we say real time, it needs to be deterministic, right? So the packets of communication across the network of edge devices has to be deterministic. And we apply a standard called time-sensitive networking, which is an IEEE standard, to make sure that the network security is deterministic, it's secure, and it's reliable. And wireless is the future. When we talk of autonomous factories, which can reconfigure itself, you have humans, you have robots, you have guided vehicles, you have assembly line. You cannot wire everything to be sustainable and flexible. It needs to be wireless, right? And in the past, wireless was not affordable, or it was not secure, it was not reliable. But today, it is available, right? I mean, if you look at everything is connected, right? We have smart homes, we have smartphones, we have TVs. So wireless is possible, even in the critical infrastructures, with the standards coming on board, like TSN over 5G, Wi-Fi 6. It is very much possible to have a wireless autonomous systems in smart factories and smart grids and areas like this. So definitely wireless is the future. We've done a lot of proof points within Intel with our end customers. So it is very much future, and the future is here. We are developing an ecosystem of partners that are bringing the solutions together.
Thanks, Sunita. That's very interesting. Jordan, I'd like to go back to you now and ask, we just heard a bit about connectivity is the future. Can you talk about the importance of connectivity, and how do we get it right?
I think that's, one of the most important elements, I think, is how do we have this technology talk to each other and talk to networks? And, I think, some of the issues out there, to really put it in perspective is, we need a tech neutral approach, to get an ecosystem wide connectivity policy right. And that requires wireless, that requires 5G, that requires licensed, unlicensed spectrum, and getting that right balance there as well too. But it also, requires other novel forms of connectivity as well. I mean, that could be satellite based, or something like with the Starlink that we've seen so far. I mean, it could be a variety of different options, and I think it's best that we diversify when we take a look at connectivity options. A few areas I think that make a lot of sense though from a policy perspective when we're looking at this issue. I think the private sector does a really good job of leading on these issues. They develop the technology the best at scale. And I think when you look at private sector driven networks, they tend to be more resilient. And I think one of the things we need to make sure is that the private sector continues to lead the way, but there are also times when government needs to provide assistance monetarily. And when government does that, government needs to provide money for those areas that truly lack service first, so that we get more return on investment. For example, here in the US, we have 19 million Americans who lack access to 25.3 speed broadband. And, for the United States, we'd argue those dollars should go to areas like that don't have service before it goes to other areas across the country. Permitting is also important. As we're looking at 5G, for example, there are a lot of localities that charge exorbitant permitting costs for each time a pole or a small cell goes up. We need streamlining there, and probably more funding for permitting offices to ensure that we can get the devices and cells placed there, as well as the edge computers. And so those are definitely some areas I think are of importance, and making sure we get the right mix of the public policy on spending, but also making sure that we have good regulatory policy on permitting. But also we have to make sure that our technology is a mixed, diverse portfolio of connectivity, whether it be fiber, satellite, or wireless.
Thanks, Jordan. That's actually a lot to think about, and some of the data you gave is really interesting. And I think we'll be also looking quite a lot about more remote areas and the solutions that can be offered. And I think the combination you talked about, private sector and government, it's probably there's a path somewhere there. I would like to ask next Michael. Michael, can you tell us a bit about what mechanisms are being integrated into edge servers for security?
Yeah, so this, as I said before, is fairly a hot topic. So there's two levels. I would say Intel themselves are doing a lot of work to improve security, particularly on server class devices. So they've added their secure enclave onto the system, so you can run some of your boot code and additional code within that and keep that protected. And we now have full memory encryption. James was talking about encryption before, so now we can encrypt the entire server, the memory database as well. Of course, the challenge as soon as you have encryption is you now get into the joys of key management. So you've got all these remote devices that are spread out all over the place, and you lose your key or you lose your change and you've lost that. And so we start to see some add-on type solutions, particularly with Hub Security, looking at some of the FIPS models that's really been identified to lock down and secure and provide that encryption capability and to provide that key management in a way that's very secure between the two. So we start to get supplementary technologies that sit over and above what's been built into the server itself. So, for example, I mentioned, and James mentioned, reducing your attack vectors into the product. If you take all your Ethernet ports and you run them through a FIPS card, you can basically protect everything that goes in and out the server. And this, again, is a little way where an edge server starts to differentiate from a data center server, where you rely much more on, on a degree of physical security. Yeah, you have to authenticate and certify the device itself, even basically at the BIOS and raw connectivity level. We spoke a little bit about connectivity, and this is, I think, an area where 5G, that's a space we're pretty active in, particularly around private 5G. So you've got macro 5G being used as your connectivity from your edge side back to your cloud. You've got private 5G providing local resources. But one of the things I would say that 5G does bring over a Wi-Fi connection is an extra element of security because of that SIM card. Not that Wi-Fi can't be secured, but SIM card also gives you a means to distribute that security. By enabling that SIM, you can secure that device and make sure that when a device is connecting, it's a device that's authorized to connect to your network. So, again, following the sort of zero trust model, particularly with physical devices, the other area we started to see, and the mobile operators are well aware of this, is you start to decommission these devices. So we're starting to see, drives that are encrypted or locked down and can be wiped. So when you turn a server down, you don't just want to send it off to someone. It's like same as your phone, right? You want to wipe your phone so it goes back to raw data, and that needs to be factored into the servers as well. So it's not only day one, but sort of end of life security needs to be considered as well.
Thanks, Michael. I would like to move now back to Jeff and ask a bit about more in depth about technology. If you can explain to us how can the edge deliver in data center or cloud-like availability for applications, a bit about the technology that enables all of that?
Sure. I think that at the end of the day, right, what all the customers want is whatever application's running at the edge has to keep running, right? I mean, that's sort of the point of all of this. And I think before I get into much there, I did want to comment a little bit on what Michael was saying and what James had said, right? Because I've seen, as I said, I've seen edge deployments now for years and years. And oftentimes we go into a customer who had something at the edge, and sometimes maybe that something went wrong, which is why we got called in to begin with. Some security at the edge is sort of very basic and common sense, right? It's kind of like put your seatbelt on in the car. That doesn't mean you're not going to get in an accident, but it's still a good idea, right? If you have a device that sits out at the edge that other humans have access to, turn the USB ports off, right? I mean, this is like one-on-one. I guarantee right now, James could walk around the airport. He will find a live USB port somewhere that he could stick something in, right? And hacks happen that way, right? And it just seems dumb, but I mean, it is the kind of thing that we see. And, if you can deploy systems out there, and Michael was getting at some of this too earlier, I think, where, okay, the system doesn't need a, keyboard, video, mouse to get set up, right? That's good, because you don't want those ports just out there, flapping. Some applications require USB dongles, right? And that means there's going to be an open USB port, and these are just things you have to kind of work through. And physically securing those things. I mean, we talk about, you go into a data center and they have, your servers are in a cage physically separated from somebody else's, and then you go out to the edge and they've got 3 tower servers sitting on somebody's desk in the back of the grocery store, right? Like what is going on here, right? And so you have all of that. I think that, kind of coming out to the high availability and keeping applications running. I mean, the technology that we've applied to our operating system is an AI technology, right? It's using pattern recognition to effectively deal with the fact that you don't have on-site IT personnel, right? So when something goes wrong, IT personnel, go on a hunt to try and figure out what went wrong, right? And that's one of these things that can be done by AI, right? We can look at all the situations, how much free space is on this drive, what's happening with this network port, what's happening with this application. And these different conditions make a pattern, and those patterns can very often tell you what's wrong with the system even before any human would ever know something was wrong, right? And then use software to take the steps IT would take to keep the applications up and running. And it's important, in our use cases anyway, it's important that this intelligence exists at the edge itself, because it might get disconnected, right? It might be intentionally disconnected, as in my oil tanker example, right? These sorts of applications, you need to deal with the fact that, when the oil tanker has a server that fails, which will happen, right? Power supplies burn up and these things. You don't want to send somebody on a helicopter to go chase down the ship, right? It's a huge problem, and you can handle all that with software. And that's ultimately, what we try to do at scale is built into the operating system itself is the concept of high availability, so that any application you put on it will have that high availability built in.
Thanks. Moving from Jeff, I would like to ask Peter another question about, actually, would like to know if we can leverage AI on the edge for data security, or is there in comparison? How can we leverage AI on the edge for data security?
Well, like Jeff mentioned, right, you can use it for pattern recognition and recognize patterns that are not supposed to be there. That's obviously a clear path. But as I said before, because, well, data privacy is such a big issue, you can basically encrypt your data in a way that is still workable for the system running behind it. There's probably a lot of information that you don't need and that you can sort of get rid of. And you can, well, typically machine learning algorithms, I guess you guys have I've heard of deep learning. Deep learning works in multiple layers that are stacked up on top of each other. And each of these layers process the information one way or another. But the higher you go up, the much harder it becomes to extract what the original thing was. So basically what you can do is run, because most of these algorithms are too heavy to run on the edge, not always, but quite often, you can run part of it on the edge where you already do part of the computation, but while you're doing that, you're actually encrypting the data and making sure that whatever you send over is not accessible. So in short, it means not storing anything that shouldn't be accessed and making sure that whatever you do store or send around is in a format that is pretty hard to, well, extract or find the information that you try to hide, right? It's not that that's always possible, but that's one of these tricks you can apply, right?
Thank you for that. Before one more question about security, I would actually like to go back to Sunita and ask about if you can specify a little bit about the major business drivers for edge computing.
Yeah, good question. I think it was Jeff who mentioned the technology drivers for edge computing, right? I'll talk about the business drivers. So every customer, any vertical, they have 4 main KPIs, business KPIs, right? They're looking for how do I, manage my costs, right? Whether it's the CapEx or the OpEx. How do I improve the quality, the output, the yield of my products, right? That's number two. Number three is how do I manage my business sustainably, right? Sustainability has always been around, but it's now becoming more forefront, right? And four is how do I secure and keep my assets safe, right? And when I say safe, we're not talking necessarily just cybersecurity, but safety as well, right? How do I keep my critical assets, whether it's their human beings, their machines, their IP, their data, everything safe, right? So those are the business drivers. Now, the other thing that's happening, and we saw that the pandemic got a huge realization, is the business needs are dynamically changing, right? So let's take the vertical that we're focusing on, manufacturing, for example, right? When the pandemic happened, several manufacturing plants came to a standstill, right? There was worker shortage, people couldn't go to the factories, there was supply chain issues, there was a number of issues that caused this manufacturing, right? And there was a need for new products. Like, we all heard about the toilet paper fiasco in the US. The factory started to reconfigure to create ventilation machines or masks, right? The same. So how would you do this if you were not really designed to be modular and reconfigurable using software-defined modern practices, or not use USBs to update software and things like that, right? So those that had preempted this modernization of their infrastructures survived the pandemic, right? And they're building more and more advancement in their modernizing their infrastructures. So the business drivers are really the four basic KPIs that every business, regardless of which era you are in, has. And on top of it, how do you prepare for an unprecedented event like the pandemic, right? I mean, it's the war now, it's a pandemic yesterday, we're continuing to be in this constant dynamically changing world, right? And that becomes a business driver for you to modernize your infrastructures.
Thanks, Sunita. Before we move to the Q&A, Joe, I'd like to go back to you and ask you, besides physical security, what other security measures can be taken to help ensure the security of data on the edge?
It's kind of funny, we were mentioned about James being in the airport and how there's probably a USB port just sitting there waiting for him. And that kind of struck me kind of interesting, with an interesting twist, because there are tools that are around to exploit just that kind of thing. In fact, here's one of those devices, right? Looks like a little, you remember the old Tamagotchis, right? This is basically it's a hacker tool, effectively, right? For research or for bad actors. And one of the things it does is bad USB. You can put scripts on here, right? Looks like a little toy. You're sitting there just playing with it, but all I've got to do is plug that USB cable into it, plug it into the machine, execute whatever script I want. Fortunately, I've only got Rick-rolling scripts in here, so no harm, no foul. But it's not difficult for someone to go into an infrastructure that's not protected by the four walls and accomplish something nefarious. And James is in an airport. There's cameras everywhere. There's people everywhere. But when we talk about the edge, that's not always the case, right? In a retail environment, or again, at the base of that cell tower, right? You may not have that luxury of having a number of deterrents to someone performing a bad act. When it gets down to it, though, the thing that we really need to keep in mind is the attackers are not after the network. They're not after the server. They're not after pretty much anything except that data, right? And I will agree and disagree with James a little bit. I've spent most of my career in encryption. And yes, encryption is an extremely valuable tool. But one point I want to stress is that encryption is not security. Encryption is a tool that can help you achieve security, but encryption is not itself security. You need to combine other elements to cover all of these open vulnerabilities and open access points that we have, like USB, like the connectivity that Sunita was talking about. And because we don't have the four walls, we have to rely on other methods of securing those endpoints. So encryption is one way to protect that data, but we have to look at what can those remote people access, right? Not only do they have the connectivity, not only is that connectivity authorized, but once those authorized people are connected, what can they do, right? Is everything that they are capable of doing something that they should be able to do, right? So of course, one of the things that we look at Hub Security is how do we prevent our good actors from doing things that they probably should not be authorized to do, that the applications or that, let's say, the environment, Docker, Kubernetes, et cetera, will allow them to do, but maybe is not in the best interest of the business. What about the bad actors? Are we making sure that if something is being done that doesn't look kosher, right? Doesn't look very good, meets an AI point that we think exposes something is going on that isn't what we expect. Can we take action, report it, block it, do something, because we don't have that physical security around it. We're used to talking about defense in depth, right? And in the data center, we look at defense in depth as firewall, VLAN, right? Server hardening, and then we look at encryption and whatever else we can wrap around the security itself, right, around the data itself. But we don't have that in a lot of these environments that we've been talking about today. And so it's very important to look at it with maybe a fresh perspective of what if I took this server out of my data center and put it in the middle of Main Street? How can I prevent that server from being exploited, the applications on it, any vulnerabilities that are found in those applications or the operating system or the environment from being exploited? And how can I make sure that that server sitting on Main Street isn't compromised, has its data compromised? Right. So one final point, we talked a little bit about GDPR and how that we don't want that local data to be exfiltrated and moved somewhere else, right? But there's also GDPR requirements to secure that personal identifiable information. So it's not just about can that data leave where it is and move to some other country, some other location, but if that data is compromised, where it was generated and where it's stored in that local environment, do you have exposure? And under GDPR, you do, even if you're not in a GDPR country, even if you're here in the United States, where the bulk of us are. So these are the points I think I would leave everyone with is imagine that server is put out in the middle of Main Street. What would you do to secure it? What are the technologies that we've talked about today that a lot of the companies here on the panel can offer you to help lock that data down and make sure that it's not misused, exfiltrated, abused, even if it's encrypted?
Thank you, Joe, for that. And I think, first of all, I think after talking about it a few times, I'm going to check a few of the USB points at the next airport I'll be visiting soon. So thanks for that. Before, you need to email me that. First of all, thank you everyone for the very insightful discussion. I think we covered quite a lot from the private sector, government, wireless and edge coming into play with security, business, and we covered quite a lot of ground. Actually, I was so interesting, I gave it a little bit more time than I should have. So thank you for that time. We have a few questions that came from the audience, and feel free to, we'll start with the first one. Said Inaj is asking, with the advent of metaverse and considering that AR and VR devices are edge devices, they tend to collect a lot of personal data. the policies, methodologies, and tools that would allow the consumer to have control over their data and privacy, which I think is a great question. We also talked about privacy and GDPR and so on a minute ago. Who would like to take that question first?
I'm happy to take it.
Sure. Go ahead, Jordan.
I think AR and VR are, a very interesting and fascinating field. And I think, some of the great applications for that are everything from like workforce training. And, we're hearing about like even hospitals when we were at the Cleveland Clinic, using AR and VR to train doctors in a more realistic setting without having an actual patient that they're working on. But in terms of the privacy aspect, AR and VR do deal with a lot of what I would describe as sensitive data, and whether or not that's dealing with, something like gait, or that's dealing with, something like, retinal scans or anything like that. Those are all kind of sensitive, kind of health specific bodily privacy areas. I think it's key for companies to be transparent about how that data is collected, how it's used, and how it's shared. And given the fact that it is sensitive generally in a lot of cases to get consent before that's shared for any purpose with other entities for purposes not really described by the company or by the provider. And really too, I think it's a good practice just to take a look at what laws apply as well. I mean, obviously GDPR applies in the European context. In the context of if you live in Illinois or Texas, if it's including any biometric data in the United States, there are laws around that as well. And then there are 5 state privacy laws that are generally comprehensive in nature. And then finally, as I alluded to earlier, there is a privacy bill running through the United States Congress that could potentially have a significant impact on biometrics and subjecting companies to lawsuits. So it's probably a good time right now for folks who are dealing with biometrics or in the AR and VR world to do a quick checkup on privacy, because I think the rules could be changing at some point soon.
Thanks. I'm guessing there'll be more rules coming into place. I know we are looking at it from a security standpoint in the metaverse, looking at the data, and there's today financial transactions happening, and actual platform identity, and so many other questions coming to that. Anyone else wants to take a go regarding privacy and the metaverse?
Can someone define the metaverse for me, please, definitively?
That can be a whole complete discussion. Of course, anyone who wants to take that are welcome. Unless we can, sorry.
Yeah, Doron, just to let you know, I think what Joe is trying to get there is the virtual reality. So I know it's getting grand a lot right now these days. One of the things that I mentioned recently in one of my trip, to embedded technology, is actually fit into this. Guys, I know that we all have Xbox, PlayStation 2. It doesn't matter which one that you are using to connect to do. It doesn't matter if you are actually going through any online devices. Don't forget, as long as you are connected to so many things, you are at the risk of being exploited. One of the things that I like, Joe, I like that you share that. I speak about the USB vulnerabilities. There's a lot of them. There's a very good one that people mention right now. They call it drop. It's called drop attack. Somebody will dress like they're an FBI, and they will intentionally drop a USB. And everybody, when you see somebody that dressed like they are security agents, there's no way and they drop something. People, instead of them calling them and say, hey, you dropped something, sir, they take it thinking that they'll be able to see something very interesting in that USB. Immediately you plug it into your system, you become my thing. Now I'm able to do anything with your system without, all of the codes are written inside, like Joe said, they already plug in. Why is this? Why did I mention all of this in the metaverse? Metaverse, you are talking to somebody. you are buying properties, you are negotiating with somebody. All of those things that you are trying to do is an exchange of transaction. In addition to the transaction, you are doing what we call communication. And most of them are by communication, dual communication. Somebody is talking to me and I'm talking to them. I don't care who you are, as long as I can reach back to you. I can embed some messages, I can embed some things inside a link that you are doing. Being a man that's very curious, we human beings, we are very curious. If I send you something and say, hey, do you want to play here? Do you want to check this property? As long as you click that, and I'm talking to Jordan this time around because Jordan mentioned a lot of fascinating things. If you click on that link, you become my thing. And that is how it is. Who's supposed to protect you? Who's supposed to make sure that the people that are inside your gaming convention or inside your network, they are not exploiting you? It's the people that are managing that platform. And if you look at it, Jeff, I believe Jeff run a lot of data centers. They can't, you can't just budge into everybody's network. That is one of the big deal. But if you go into Jeff mentioned something about pattern. And I think that the same thing with Peter. If I can understand the pattern that the network take, if somebody is trying to exploit you based on the pattern, and who can do the pattern is AI. AI is the one that can actually look at the pattern. I can say, you know what? This is an habitual network. This is an habitual traffic. Without all of this stuff, it will be so hard, Doron, to be able to say you want to protect everybody on your platform. And that will never happen. We will never have 100% security. It will never happen in our lifetime. Simple as ABC.
Thanks, James, for elaborating on that. This rather long question, I'll try to kind of split it, and we literally have only a few more minutes, so let's try to keep the answers short so we can get through. Abhit Kudromati is asking if we can comment on the security of, the scalability of security solutions at the edge, not serving a massive data stream. There's more parts of this question, but this is the first part. If you want to talk about the scalability of security solution for edge, I would like to take this first. Michael, Joe, anyone?
I'll take a shot. I don't think that the security itself is a problem from a scalability point of view. I mean, your edge system is being handled, is being required to handle the data itself. The amount of additional work to secure the data, we've spoken different ways through encryption, is not relatively that high compared to the data that you're dealing with. Other methods that we spoke about, securing the device itself, locking down the device, restricting management access to the device, is all sort of kind of built into the system. Of course, you have many systems that collectively add up. At the edge, you only really, the nice thing about the edge is each device itself is a little island and only has to deal with its own degree of traffic that it handles. So obviously the device itself is going to be scaled to the traffic that you anticipate that it's going to get. So I think it's more of a design issue than any kind of fundamental philosophical issue.
Thank you, Michael. Anyone else wants to add to that? Oh, we good.
I may make a quick comment actually, because I think the last question and this one both do touch on something, which is, there is some overlap between, we've been generally talking about this from a business perspective, right? But then this also spills into home users, and James brought up the PlayStation and this whole thing, right? While we were talking, I did a scan. I've got 47 devices on my home network right now, right? I don't even know what they all are, right? I'm just looking at the list, right? Here's 47 things, right? When I talked about those tower servers in the back of the grocery store, right? One of the big security problems is there's no IT person there. Nobody's going on site and patching software. Nobody's patching the operating system, much less the BIOS and the application and those things. And then when you take that out to the extreme, okay, I've got I could go on Amazon and buy one of 1,000+ different video cameras to do video at my house, right? Some of those companies are going to have crappy software, and that software is going to have to get patched. How many times is grandma going to patch this software in her camera? Like hardly ever, right? So you just have these massive challenges. And I don't know, I don't have a magic solution to it, right? I mean, at my house, I run all these devices on a separate network. I mean, most people don't do that, right? I mean, you should, but they don't. Because they don't even know how, right? And so, there are a lot of challenges. And when you think about like the metaverse, okay, it's much like the camera, right? I can have one set of VR goggles or another goggles, or somebody has, I got a device that I wear on my hand that I can feel things. Well, again, that's going to have software on it. That software is going to have bugs. So, I do think that, securing networks is certainly a key piece. James talked a lot about that, right? The aggregation points is a big deal. You can't possibly fix everything, but to the extent that you can, have a system in place where you can update these sorts of devices, it's really key, because it's all software, and software has mistakes. So.
And if we kind of look at the incident we saw recently, where a DoD acquired smart card reader from a Chinese manufacturer had malware in the device driver, we start looking at specters like that can add another layer of vulnerability to things.
Thanks, Joe. And we are actually going into overtime, so we won't unfortunately be able to answer all the questions. I'll hand over to the speakers and we'll try to answer offline. I have to say this recording was also going live on YouTube and LinkedIn and on both channels, and will be available, and will be a complete edited version by in the next few days. I really want to say a big thank you to all our speakers on the panel. This has been extremely interesting. I know I learned more, and I was surprised by things that were actually even new to me. I would like to personally say thank you to Sunita, Michael, Peter, James, Jeff, Jordan, and of course, Joe. I hope everyone found this discussion interesting and insightful as we did. You can find more about Hub Security on LinkedIn, Facebook, Twitter, and on any other social channels. And you can also approach any one of the speakers directly. And we hope to see more of you in one of our next events. Thank you all so much for your time and the discussion we had today. So thank you very much, and hopefully to see everyone of you next time.
Right, thank you.
Thank you.
Thanks for having me.
Thank you.
Thank you, Doran.
Thanks, everyone.
Thank you very much.